Hello everyone, I'm very happy to be with you today, and today inshallah we will go through some problems and making a recap about the previous lecture. So I've thought to summarize all the what we did go through the previous lectures. We are having a summary of limits and multi-variable functions. That's a part of math analysis. This is actually will cover the slides 8 and 9, and we will go through slides 10 also today inshallah. So I want you to remember that in order to find a limit in the multivariable functions, this is the first or the start, which states that for an f of x and y, it's a function defined near a point AB, but not necessarily on this point. So it's defined on the neighborhood of this point. We say that the limit xy into AB of a function or the kernel f of xy will equal to L along a certain curve. If the values of f of x approaches L or xy approaches AB along points on one curve or a specified curve. This is not a full limit because it's partial test of the limit by restricting the bus. The problem with multivariable functions is actually that you have a lot of buses or curves that will lead this function to approach this point exactly. So the following remarks, as you know from the previous lectures. So first of all, you should know that if the value of f of x approaches L, approaches AB along points on a curve of C, this is not a full limit, it's partial test of the limit by restriction to a bus. Also another remark, in multivariable calculus, approaching from different directions or curves may lead to different results. So if I'm trying to approach certain point from various curves or from various paths, I may end up having various limits. Unlike first variable limit, we have infinitely many directions and the buses approaching certain point in R2, which means that it's not that easy to find the limit. You will have to try to go through most of the curves and this is not an easy task to do. Also, if the limit is different along two different curves, so if you end up having a different values for certain limit through different curves, then the overall limit doesn't exist. This is actually a very important slide summarizing the differences between the limits or the lateral limits and the limits of an f of x or y relative to a certain point. Relationship between general limits and limits along the curve. Bottom line, the limit in multivariable function will exist if it has the same value through different curves. Otherwise, if at least it has two different values from just only two paths, then this function doesn't have a limit or the limit doesn't exist at this point. So once more, the limit of multi-differential function will not exist if it has different values through different curves. So this is a major check that should be done and in order to discover or in order to find the limit through a certain point. Definition of a limit by the definition or the Cauchy definition of a limit of a two variable. This is really very important definition and it makes sense and needs some skills. We will shave it today on more than one problem when we are solving the sheet of this part or the set of problems or exercises about this part. So the theory in general states that if f of xy be a real valued function defined on some neighborhood of a certain point, except possibly at this point. So it's an accumulation point or around AB. So if xy tends to AB for a function, the kernel f of xy, for this limit to equal to L or to be exist and equal to L, we must have. So this limit exists and equal to L. So if and only if we must have, for every epsilon greater than 0, there is exist delta greater than 0. So for every epsilon greater than 0 and delta greater than 0, such that the norm of the distance between xy and the AB, which is simply in the square root of the difference, the square of the difference between the components. So simply x minus a to the power of 2 plus y minus b to the power of 2 under the square root, as you can see. And this value is less than delta. Then the difference between the function and L should be less than epsilon. So once more, for the Cauchy definition of a limit, all what we are searching for, or in order to understand or to know if this f of x or y equal L, all I have to do is to make this check. That's for some value greater than 0, which is epsilon, and for delta greater than epsilon, we will have the norm of the distance between xy and the AB less than delta. Then, which is the result, that we will obtain that f of x or y minus L less than epsilon. If this exists, then this function equal L, and that's the general definition of the limit in two-dimensional multivariable functions. Sometimes we need to use polar coordinates, and it's really very simple, and it sometimes it will make things a lot easier using the polar coordinates. The polar coordinates, we really did go through this previously, and it's very simple. That's x is equal to a plus an r cosine c, and for the y component, it's p plus r sine theta. Plus r sine theta, I'm sorry, where r goes from 0 into r, which is the neighborhood of the point that you are approaching, and for theta, it will go from 0 up to 2 pi. So the definition once more states that for a function f and r theta, which is defined by changing into the x y using this transform ar cosine theta and br sine theta. F, the absolute of the difference between f r theta minus L is less than or equal some function in R. Doesn't depend on theta, some function in R. And once you take the limit of R tends to 0 of this mr value or this function in R, it will go to 0, which means that f of r theta is equal to L, or the limit existence equal to L. So once more, all I have to do is to just making the change, okay, using the polar coordinates, then trying to simplify the integrand, or try to simplify the kernel as much as possible, which is the function that you are studying the case of the limit for minus L. Try to simplify this till you reach a function r as time theta, and when r tends to 0, this function tends to 0, which means that f r theta is equal to L, and the limit existence is equal to L. It's very, very simple and helpful in a lot of ways. And also we did do that in the previous lecture. By the end of the previous, the last lecture, we talked about the iterated limits. And the iterated limits in the multivariable function, the two-dimension, just to focus on one thing. We will do within an order, taking the limits of the function step by step. So for example, if I have f of x and y, I can take the limit first for x tends to 0 and finish the substitution, then I will do limit y equal to 0. And also I should do the vice versa. So first of all, I will take the direction of limit x tends to 0 over f of x y, and then take the limit of y equal to 0. Then I will do the reverse of this process. I will go first for y equal to 0, then for x equal to 0. So this is mainly the first step, and that's number 2, which is limit y tends to 0. Then taking limit x tends to 0. So we will go both ways. If these two functions or these two limits have the same value, exist, and they have the same value, so it's a good sign. Okay, but from the beginning, if these two values not equal to each other, so this limit doesn't exist. That's the main positive side using the iterated limit. If it doesn't exist, so it doesn't exist. But if it exists, it's a good sign. So if these two iterated limits exist and they are equal, it's a good sign, but it doesn't guarantee that the two variable limit exists. So you can use the iterated method in order to be sure that the limit existed for sure. That's a good sign if they equal to each other. Then go to the next step, either by various curves in order to be sure about the general limit value, or do the definition in order to get the value, exact value of this multivariable limit. Of course, once more, the general limit f of xy, when xy tends to 0, means you are approaching 0, 0 from all possible passes in the plan, not just along lines or axes. It is required the function to get arbitrarily close to a single, no matter how the approach to the point. Same thing as we said more than once. For the continuity topic, which is in the general arrangement of discussing something related to differentiability and its application, you will go through continuity. So for a function in 2 dimensions or in multivariable variables, the continuity of 2 variable function at a point, let D is a subset of R squared. So for x node y node belongs to D and the f from D into R, we should have the following: that the limit in the neighborhood of the point equal the function value, or the definition equal the limit, which is exactly the same for any function to be continuous. If you remember, for any function to be continuous, the function should be defined. Number 2, the limit should exist at this point. Number 3, the limit and the definition should equal to each other, so it's exactly the same thing. We can write that exactly as the definition. If you remember the definition for an epsilon and theta and delta greater than 0, we have x and y, or the norm of xy tends to a and b, less than delta, and we have the function f of x minus L must be less than epsilon or vice versa. It's exactly the same in here. That's for any epsilon greater than 0 and delta greater than 0, we have the following: that xy minus, or the norm of xy minus x naught y naught, should equal to f of x y minus L. Here L, which is the value of the limit, equal the definition, so we just replace it by the value at this point, and this completely makes sense. It's the same. So if Z is said to be continuous on a set A belongs to D, it should be continuous in every point, exactly like the continuity in 1 dimension or in the lateral dimension. Now I would like to speak with you about some problems from sheet 5, which is an application of a level curve on level curves, or application on the limits. Okay. Here we have the limits and the continuity, some limits and continuity problems, as you can see. Using definition, the first set of problems asking you using the definition, so I will use the Cauchy definition of a function at a point, and showing that the first limit, which x, y into the 0, 0, of 2x cubed over x squared plus y squared equal to 0, then the limit for xy to 0, or to the origin, also 2x squared minus 4xy plus y squared divided by the root of x squared plus y squared equal to 0. So I want to check about these two guys. Also studying the existence of the following limits, These are some limits, and I want to discuss the existence of these limits. Here, analyze the continuity of the following functions, and you have more than one problem. I probably will solve some of these continuity problems, some of problem 2, and I will solve with you problem A. If I went to problem A, and before starting this, okay, here's these two problems. We will go through them step by step. Okay, perfect. Using the definition of the limit of a function, and we already did go making a recap about it. Okay, for these two guys. So the steps are really very simple. The first step, you will have to bound the denominator, because mainly the function by itself, what's controlling most of it is the denominator. I will show you one example in those or in the coming set how to bound the denominator or how to manipulate this point. So the first point or the first step, bound the denominator. Number 2, step number 2, bound the entire expression. So I will need to have a bound, okay, an upper bound for this definition. Number 3, apply the definition. Remember the definition, it's the 1000 times that I stated this definition for you, because I know in the previous lecture, once we introduced this definition for the first time, it was a little bit hard to digest. But I believe now you are familiar with it. So all we have to do for a function f of x, f of x and y to equal to L, we should find epsilon greater than 0, delta greater than 0, such that the norm of the distance between xy and the point that you are approaching, let than some value greater than 0, and you will have to prove, and all these steps, it's about f of x or y minus L less than epsilon. Also, there is useful relations in the boundedness of the kernel. As I told you, that's a summary of all what happens previously. So I need these statements to be in mind in all times. First of all, remember that r equal to the root of x squared plus y squared. That's an equal sign, and you already know that better than me. Okay, note that also absolute x is less than or equal to r, and we already did go through a long discussion about this in the previous lecture. So an absolute of an x is less than or equal r, and also an absolute of an x is less than or equal the root of x squared plus y squared, and that's the main discussion. Also, absolute of a y is less than or equal to r. So these two guys is really very important. Also, remark that x squared plus y squared is greater than or equal to x squared, and it is the same debate. Once you try to understand why absolute x is less than or equal to r, it's exactly the same like trying to understand that x squared plus y squared, for sure it will be greater than or equal to x squared. You may need this, that, and of course this guy. Also, remember this. I know it makes sense, but sometimes you will lose it. I have the square root of x squared plus y squared, which is r. And since root of x squared plus y squared, from the assumption it's less than delta, this will lead also that r is less than delta. And knowing just only these simple facts, it will make a huge difference in the treatment of your problems, as you will see. Okay, now let's start with our problem. I need to find the general limit of xy tends to the origin of a 2x cubed divided by x squared y squared, and the limit existence equal to 0. We need to check that. Okay, we will use the definition. Okay, so we are working this function using the definition. And remark that x and y tends to the origin. So mainly we don't have to do this first step. Let me focus on what we are going to do. This problem, the limit exists, and the limit is equal to 0 and 0. So I don't have to do these steps. I need to just only to go through the discussion of delta and epsilon. But since we are starting this problem, I thought to start it from scratch for you to understand how we go. So mainly consider that we don't know it's equal to 0. We need to identify first the value of this function. According to the general definition of a limit in 3 dimensions or in multi-variable dimensions, we should have a limit for this function equal, and it's going to be constant for various passes. So, approaching the origin along the different passes. I will try pass number 1, which along the x-axis. So, before we start this, and once more, we don't have to do these steps, but I'm doing these steps considering that if you don't know the limit. But in this problem, you know the limit, you just want to check if it is the general limit. But if I don't know it, all I have to do is to do the following. Just to check, and that's the simple thing that you do. Just to check through different or various passes. I will start with along the x-axis. What's the equation of the x-axis? Y equal to 0. So I will take the function, start substituting with y equal to 0, and once you do this, your function will be 2x cubed over x squared, as you can see, which can be simplified to 2x. Now take the limit on the value of the function, so it's a limit over 2x, while x tends to 0, so it's going to be 0. So the limit for this function already exists, but on the first pass, which is the x-axis. Let's do again what we did, but on the y-axis. The y-axis, it means x equal to 0. Similar manner, similar treatment. I will just go putting every x equal to 0 in the kernel of this limit, and you will have 0 over the value of y squared, which is simply 0. Now, the limit, once y tends to 0, is equal to 0. So these two guys are equal to each other. But this is just only 2 curves. I need to check on one curve. So I will choose also to check at y equal to x. So all I have to do exactly like what we did here is just to try to substitute instead of y by x. So it's going to be 2x cubed divided by x squared plus x squared. This is exactly what happened. So you will have now 2x cubed over 2x squared. The 2 will eat the 2. So this, after simplification, is going to come up 2x. Taking limit x tends to 0 for this guy, you will end up also having 0. So it's a very good sign. Now I have tried the 3 curves or 3 passes, and I ended up having the same value. Okay, let's try on any value in x. The straight line y equal to n of x. Same manner, same treatment. I will start removing y or replacing y by m and x. So I will have 2x cubed x squared plus m squared x squared. Taking x squared as a common, from here, and eliminating it with x cubed, you will end up having this kernel, as you can see, 2 over x plus divided by 1 plus m squared. Taking the limit of 2x 1 plus m squared while x tends to 0 will also end up having 0. So through all of this, the limit exists and it's equal to 0. So most probably, okay, let me do another check. Why not to check if y equal to x squared? So see how many passes we try. So I will go through y equal to x squared also. So if I want to do this, I will have 2x cubed divided by x squared plus x to the power of 4. Once more taking x squared as a common and simplifying a little bit the kernel of this function, I will end up having 2x over 1 plus x squared. If I took the limit now for x tends to 0, the denominator will force this value to equal to 0. Now I'm sure that the limit equal to 0 for this guy. Here we go. This is the limit equal to 0.
What's the criteria to choose the passes here?
Just only the main passes, y equal to m of x, y equal x squared, y equal to x, one of the x's. I can just use these 2 guys instead of all of this, but I wanted to show it to you on more than one curve. Remember, this is not enough, because exactly as you said, there is infinity of curves making this function approachable to this point, okay? This is why we will have to use the definition. So that's the first point.
Which is
Yes, okay? So that's the first point. Just to check if the limit possibly will exist. And also it's very good step, like the iterated method. Because if you have different values, you don't have to proceed. You don't have to go through the definition. Do you read me now? Okay, perfect. As I told you, this step 2, you don't have to do it. The second step. But also I insisted on going through it just to make a revision. So we made a revision on how to study through various passes. And now I want to take you and go through the theory if you want to do this with polar coordinates. All I have to do is to use x equal to r cosine theta and y equal to r sine theta. And why I'm choosing these two guys, because the points that we are trying to approach is 0 and 0. Okay? So now all I have to do is to just start substituting in this guy. So this is going to be r squared, and for the denominator, it's going to be replacing x by r cosine theta, so to the power of 3, it's going to be r cubed cosine cube theta. So once more, you can take r squared, eliminate r squared with r cubed, you will end up having some function in r according times cosine theta. Now, I have, once we started to make the movement through polar coordinates, we have an mr function, a function in r, regardless of the value of theta. So once you take the limit, changing, and you take the limit for r tends to 0, the value is going to equal to 0, which means the limit exists, bottom line from the polar theory, or from the application of the polar coordinates on the Cauchy theory. So the limit exists already, and it is independent on the plus of theta, blah, 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 so it's equal to 0. The real solution, or what's required from this problem, starts from here. Starts from, we already know that the function limit already existence equal to 0. So I will start applying the Cauchy principle. I will start assuming that we have an epsilon and the delta greater than 0. And then now I will need to prove that f of xy minus L, it's less than some value greater than 0. This value, I will call it epsilon. So all I have to do is to take this kernel minus 0, and this is exactly what's going to happen now. So I will have 2x cubed, as I told you, 2x cubed, divided by x squared plus y squared, and I want to prove that it's less than epsilon. How to go through this? I will start from this definition, 2x cubed over x squared plus y squared. It's equal to 2 of the absolute value of cube divided by x squared y squared. Now you have the option to move through r if you wanted to, or remark this point. I need to see the inequality issue. I have now 2x cubed over x squared plus y squared equal to this guy. Look to this. We already know that for x squared plus y squared, this value is greater than or equal to x squared. Please remark that I know, all of us know, that x squared plus y squared is greater than or equal to x squared, regardless of the value of
Because
y.
the y value will always
Yes?
be positive. Y square will always be positive.
What do you mean?
Yani y square is always going to be positive. Yani.
Positive, negative, 0, it's to the power of 2, so it will make no difference for you. Yes, exactly right. Okay, so which means that x squared plus y squared is greater than or equal to x squared. Perfect. How to get use or to get benefit from this? Okay, that means if I want to decrease the denominator, the value will be much bigger. So now taking advantage from this fact, so that's 2x cubed over x squared plus y squared is less than or equal x squared. So now I have the inequality issue. I can simplify life 2x cubed over x squared. They can be simplified to each other, and we will have 2 equal to absolute of an x. Now I will have to get back once more. This is the fact that we just reached it, that absolute of an x the value of your kernel is less than 2 absolute of x. Also with the same debate, we already know that the square root of x squared plus y squared, this is was the first assumption less than delta, which means that absolute of an x, of course, less than delta. Using this fact, okay, exactly based on this, which means that for the kernel, which is 2x cubed over x squared plus y squared, for sure it's gonna less than or equal. Replacing absolute x by delta, so it's less than delta. Now I can use or choose epsilon. So I will choose epsilon such that it's equal to 2 delta. So at the time being, we have proved that 2x cubed over x squared plus y squared for some value which is delta greater than x squared plus y squared, less than epsilon, where epsilon that choose the value is equal to 2 delta, that's delta equal to epsilon over 2. That's the link between epsilon and delta. Now, reaching this fact implies that the limit already exists and it is equal to 0. So once more on the slides, as you can see, now we have x squared plus y squared equal to delta squared, which coming from this guy, and the absolute x is less than the root of x squared plus y squared, which means it's less than delta. So the kernel of this limit will be less than 2 delta. I will choose epsilon equal to delta, which means delta equal to epsilon over 2. So now the definition is satisfied, and we now know that 2x cubed over x squared plus y squared equal to the origin. This is how to justify a limit exists and it's equal to a certain value. Let's do this once more, okay? So this is mainly the main steps that we did go through, starting from the beginning, assuming that epsilon greater than 0, delta greater than 0, and working our steps till the end of this problem. Let's redo all of this once more with problem number B. Here, this is the definition once more, and we will start from this guy and try to find certain value that's less than delta, and then assuming the value of the epsilon exactly at the same. So all we have to prove now is to find a bound for 2x squared minus a 4 over xy plus y squared, which is the denominator, divided by the norm, which is x squared plus y squared. I believe for this problem, or finding a suitable bound, which is really very simple for this problem, it's really very simple. All you have to do is to just look to your denominator. Your denominator is a 2 of an x squared minus a 4x and y plus a y squared absolute, and here's the root of x squared plus y squared. I will focus with this guy. I'm sure this value is less than or equal according to the properties, the various properties of the absolute function. It's less than 2 of x squared absolute plus, for sure, for an x absolute, y absolute plus y squared absolute. I'm sure this value, this denominator, is less than or equal to that one. Simply, it's really very obvious, because this is a minus sign, and that's a positive sign. You don't have to go through a lot of debate. But I believe also it will be very nice just to move to the R values, considering that, and you already know, that absolute of an x less than R, and absolute, similar manner, absolute of a y is less than R. So, taking advantage from all of this, I can now, instead of dealing with this guy, it's going to be less than or equal to. This can be easily replaced by 2r squared, and also the term in the middle can be changed to be 4r squared, and the last term will be r squared divided by r. So we will end up having, if you add all of this, all of this less than 7r squared over r, which is 7r. Once more, this is the kernel that you are investigating or trying to find an upper bound for this guy. So it's a 2x squared minus a 4 over an xy plus the y squared. Once more, remember that's r, okay, that's r equal to the root of x squared plus y squared, and this guy is less than or equal to delta, which means that this is less than or equal 7 over delta. So once more, I will choose epsilon equal to 7 delta, since delta is greater than 0, so epsilon is greater than 0. Now I'm sure that there is some value which is called epsilon greater than 0 governing or bounding the limit between the kernel minus the value of the limit. So once more, we are sure that this general limit already exists regardless of the path that you are using, it's equal to 0. So once more, as I told you, here we go. This is 2x squared minus 4xy plus y squared. Once you start taking the, it's going to be less than or equal to 2x squared, 4xy, and y squared. All this makes complete sense, as r is equal to the root of x squared, y squared, and absolute and x equal to r, absolute and y equal to r, and absolute of 2x squared, it's less than 2r squared, and so on. Regarding this, I will make this substitution, so it's going to be equal to 7r squared dividing on r, so it's going to be less than or equal to 7r, which means this guy, this guy equal to an epsilon. So it means that for this value, it's going to equal to an epsilon, and the limit already exists. In a similar manner, guys, for problem number 2, he's asking you to study the existence of the following limits. So here in the difference between this problem and problem number 1, in problem number 1, the limit was given to you, was known and given, which is equal to 0, and all you have to do is to just check the definition to be sure that this limit already exists